Hello there. So, my name is Jesper, and I'm here to tell the story about Solvo IT moving from Operations Manager into Azure Monitor. It's been a long journey for us, so I'll start out by just telling you where we came from. I'll tell you what we had to do and why we did it, and lastly I'll tell you what the next steps for us are that we see for the monitoring. If you have any questions throughout the sessions, feel free to ask them. Just come up to the mics and they will be turned on for you. I do have some swag up here, some socks for the good questions. It just has to be about the session stuff, not anything. So that's the only requirement. Let's get started. Some numbers first. We're running an Operations Manager environment, and we've been running that for like 14 years, I think, where we monitor customer environments. So the customers don't have to deploy Operations Manager themselves. Our environment looks like this. We have one management group. We have 3 Operations Manager servers, management servers. We have a lot of gateway servers, one for each customer at least. We have 50 plus management packs, and these are from Microsoft. It's third party, like Citrix, Veeam, and stuff like that. And then we have some internally developed management packs. I just did a quick check a week ago about all the alerts we got there. About 300 triggered alerts, monitors, and rules. 200 of them closed automatically. It was solved automatically. That could be CPU, memory, disk alerts, where it was fixed and it's closed. 100 of them was handled by us. So that's what we do. We handle the alerts, we look at them, decide if the customer needs to know about it, if it's important enough for them, or we just need to note it down to tell them later. We also have on-call for us to handle alerts for customers, or to call them and say there's something wrong with the system. So that's the environment we're coming from. And the company, we're not very big. We are 14 people. We are 9 consultants and no developers. So going into Azure was quite a step for us, at least Azure Monitor, because we wanted to automate everything when we deployed it. We wanted to make it fully automated, and we've done that, and I'll show you that later. Our journey started a long time ago, September 2013, so 6 years ago. We started moving our servers to Azure. We wanted to do the dog feeding and do what we told our customers to do. We needed some architecture there, and if some of you worked with virtual machines back then, you would know that that wasn't very easy. It was very limited, not like now where we can do whatever we like to do. So we needed to re-architecture a lot when we moved, and the migration itself wasn't very easy either, but I'll tell you more about that. The architecture from our Scrum environment looks like this, us on the right, and then we have the customer environments on the left. So a customer could have any given number of systems, any given number of servers. That could be Microsoft systems, third party like VMware, Veeam backup, whatever the customer had, we tried to monitor it and handle the alerts for them. So the migration for us to move back then, we had some focus areas there. The cost should be lower than running in our own data center, and the flexibility should be better. So we wanted to be able to grow, which Azure would allow us to do, and we wanted the cost to go down. The cost one didn't succeed fully, not because Azure was expensive, it was, but it was mostly because we ended up getting a lot more servers for other stuff. So we built new things because now we had the capacity to do it. So yeah, it got more expensive, but we also could do more stuff. The design challenges we had was sizing the environments. Disk space, disk performance was a big issue for us. This was before we had premium storage or anything like that, so we had to bundle up a lot of disks to get the performance we needed for our SQL servers. We couldn't get any static public IPs, and we didn't have any VPNs to customers. So we needed some public IPs where we could trust that they were the same every time the customer's environment tried to reach us. Also because the customer had to whitelist their IP address, our IP addresses in their environment. Then we had some challenges because we had a Cisco firewall. Doing route-based VPNs into Azure wasn't possible back then with the Cisco firewalls. So we couldn't do client VPN into the environment, which gave us some other challenges. Then, if any of you worked with cloud services, you'd know those were not very flexible, to be frank. The migration, we had a lot of servers we wanted to move. Some of them was new servers. We built them from scratch and just moved the workload. One of them was our SQL server, which had a lot of data. So we had to migrate our 600 gigabytes of database to Azure by just moving it. And we decided to do this while we also upgraded SQL and Operations Manager, just to mix it up. Make it easier for ourselves. But yeah, we had to move a lot of data, and moving that the ways we wanted to wasn't possible. We didn't get the speeds we needed, so it was back to FTP transfers just to get data to Azure. And by April 2014, all of our servers was moved to Azure. So now we've been running there for 5.5 years, and now we're going to talk about Azure Monitor. Oh, just one more slide. We only had some few changes since then. We had a migration to Azure Resource Manager, which gave us static public IP addresses, so we didn't have that issue anymore. We deployed Azure AD Multifactor NPS extension, so we could do multifactor on our RDS environment, so we didn't need client VPNs anymore. We are constantly optimizing our VM sizes to new and better VMs with a lower price, usually. So, Azure Monitor. We need to talk about why we did it and what we did. The why is, first of all, our salespeople came back to us and said, we can't sell this anymore. The customers want something that can monitor Azure and other cloud environments. And we can't do that with Operations Manager. We can do it at some point, but it's much easier selling through Azure Monitor. Then there was ourselves, the consultants. We also wanted to work with the new stuff, so we said we need to modernize this. And last but not least, the customers came to us and said, we need this feature, we need to automate more, we need to monitor Azure services. We need a lot of features that you can't handle anymore, so what are you going to do about it? Then a lot of people will say, yeah, you've been able to do that for a lot of time. Azure Monitor has existed for a long time. Before that, there was some other stuff, and you could download management packs for Operations Manager. But for us, Azure Monitor wasn't really where we wanted it to be before making this migration. So first of all, alerting in Azure Monitor has gotten a lot better over the last year. You can do alert rules and alert groups. You can integrate with third-party products, which I'll show some of them afterwards. We also were where we needed to upgrade to Scrum 2019. We didn't want to spend time on that before making this migration. So we had to decide whether or not to do it now. And yes, we could do a hybrid installation, but we didn't feel like that was the good solution the customers wanted. So we skipped that one. Pretty early in the migration, we experienced some internal dialogues where we needed to figure out what people wanted internally. We all wanted Azure Monitor, but we didn't agree on what we needed and how we were going to do this migration. So an important note about this migration is make sure that everyone agrees what you are monitoring and what a monitor is, because there are different opinions about that. To have everyone on the same page is really important for this to succeed. So to come up to what we need to do, we need a new design for our solution. We needed to replace our SCOM console. This is where the operator on duty would go in and look for new alerts. We didn't have any fancy ticketing systems or anything, just the SCOM console. We needed more automation. We needed alert remediation and deployment fully automated. And we experienced that a lot of these tools that we were looking for, they were already there. We just needed to find them. And thankfully, some of our third-party products also were excited about this, so they developed some stuff just for this. So the solution we ended up with was each customer gets one Azure subscription. They get that from us through CSP. They get one log analytics workspace where we can pull in the data we need. They get one automation count, one or more action groups. So action groups is where you send notifications from an alert. So in the basic deployment, we will just get these alerts. But now we can also offer our customers to get these alerts in their systems and integrate with their service ticketing systems and notification systems. And then they get our management packs, or whatever we should call them in Azure. I haven't really found a good word for that yet. It seems like Microsoft is also a bit undecided on what to call them. So let's just call them management packs for now. So this is the solution. The cluster environment, they get a Solvo IT subscription in their tenant. By default, we will send alerts to Topdesk, which is our ticketing system. We got a connector there from a provider called the Backbone. Then we get notifications for our on-call people through DADAC with the Signal 4 app. They are also here. So if you have any questions about that, they might be able to answer. And if the customer wants, they can get the alerts wherever they want to. But that's the basic package from us. Some of you might have seen that Microsoft did this migration themselves internally. They developed a toolkit to move to Azure Monitor from SCOM. Why not use that? Well, we wanted a different approach. We didn't think it was built for a company in our size. And there was a lot of features in there that we didn't need. Another reason was that we wanted to be able to put this into Azure DevOps quite quickly. We aren't there yet, but we want to at some point. And we felt like putting other code into DevOps would not make us comfortable enough to run that in a daily operation. So that's why we didn't use it. We did get a lot of inspiration from there. I can say that, and I think you should do so too if you are making this move. So the customer gets the log analytics workspace and an automation account. That's a very basic part. We just need to configure the retention of the data. So every customer we deploy this to, we talk to them, how long time do you want this data to be available for you? It's your cost that drives up if you need it for like 2 years. Then we need to link their workspace to an automation account. That's just simply deployed through a template. Then we want agents to send data to log analytics. This can be automated through PowerShell DSC, or you can add the configuration of the workspace through Operations Manager. There's a management pack to do that, and it's very easy to use. Or the customer can install this themselves. Usually it's a mix of all these that we use. So let's just quickly look at a template here. So how many of you are using Azure Resource Manager templates? Okay, some of you know this. This is what a template looks like. I don't want to go into any details here, but linking an automation account to a workspace was some part of this that wasn't documented when I did it. That's why I added it here. And it's just simply a operational insights resource provider we talk to, and the workspace resource beneath that, and then a configuration of a linked service. That linked service needs to have a resource ID to the automation account. That's all you need there. That way you can link it. You can also do this through the portal, but as I said, we wanted to automate everything. So templates are the way to do that. Solutions. This is what some of the things in Azure Monitor is called, as opposed to management packs. You can develop solutions yourself, and basically a solution is just a collection of data that needs to be collected and a definition of an alert. That's all. So a few different ones here. We have our own internally made for Windows servers. It collects performance encounters about CPU, memory, disk, and networking. We decided to take all these because that way we could also use the Azure Monitor for VMs solution on top of our own solution. And then we collect event logs, application and system, and only errors and warnings there, so we don't get too much data. We needed to limit ourselves because we pay for everything we collect. So unlike with our SCOM environment, we wanted to limit this. And that's been the hard part about this transition. So workloads, or workloads, as it says. We have some monitoring for Hyper-V and SQL right now. SQL, that part we got from Microsoft, their toolkit for Azure Monitor. And I know that Azure Monitor people are working on a SQL solution too. So go and talk to them so we can get it sooner. Then we have change tracking, a very nice solution from Microsoft to deploy to servers. Getting any notifications about changes to the registry, changes to services, applications that was installed, all of that. Our customers was just asking about, we want to monitor this Windows service. Is it stopped or is it running? But now they can get a lot more, and that's how we need to sell it because I won't say it's expensive if you use everything in it, but it's expensive just to monitor a service. Automating that was a bit difficult because it's not documented at all. But luckily, when you deploy anything through the portal in Azure, there will be a deployment where you can go and look what was done through ARM templates. So that way around, we got that information. Then we have update management, which is an extra service we can now offer customers quite easily and with almost no cost. And last, we can utilize the solutions from Microsoft, Application Insights, Azure Monitor for containers and VMs, and all the stuff they're developing. We can add that with just a few lines of code. So our own solution for a Windows server, it's just collecting data, as I said. We have 17 performance counters we collect every 5 minutes, and we have 2 event logs. We have some alerts defined there. It's just CPU, memory, disk space, the normal ones, and then we have NTFS file system corruptions. Then we have some workbooks. Dashboarding in Azure Monitor is quite a mix right now. You can do dashboards in log analytics solutions. You can use workbooks, and you can pin both of them to dashboards in Azure. You can also use third-party systems like Grafana and stuff like that. So we haven't really decided what we want to use, other than workbooks is very good for us to look into systems, as we can parameterize this and use it as reporting. So we're kind of going that way right now, and it seems like that's the new solution instead of using dashboards and log analytics. But if the customer has their own dashboarding, we can hook into that and give them the data so they can build their own dashboards, or we can help them to understand the data. So deploying this is done with ARM templates, as I said. We have source control through Azure DevOps. That's the only part of DevOps we're using right now, so I guess it's not really DevOps. First of all, we need to create a subscription. Then we need to deploy the requirements for everything to run. This includes configuring Azure Lighthouse, so we can log on using our own accounts, and we don't have to be part of the customer's tenant. I'll show you that part too. We're deploying the workspace, the automation account, and linking them, and then we deploy an alert group. That's just the basic stuff for us to get started. After that, we need to deploy our solutions. And we've named these, maybe kind of weird, but that's what makes sense for us. So we have a script just called deploy PS1 for deploying the basic stuff, and then the solution name in each other script. The ones I'm going to show to you is kind of the old part because the new one is not working fully yet. So that's everything in one script. Oh, let's check that. So the script is just with a few parameters in the top. Right now I just have my own environment and our production environment listed there. There's nothing secret anywhere. It's just information about the subscription and the tenants we need to deploy into. As you can see, the tenant ID for deploying into my environment is the same as deploying in the production environment. That's because we're using Azure Lighthouse, which makes this possible. If you haven't used it yet, go and look at it. It's quite a nice feature for providers to use. Then we're connecting to the Azure environment, and we just have a bunch of more variables here. This is to onboard the customer, that part, to deploy the Lighthouse configuration. And down here, we just deploy the workspace and getting that linked up with the automation account. And then we just go on. If the customer wants to monitor heartbeat from their servers, we can do that with a solution. If they want to monitor Windows servers, we can do that. We have a script for that. It's just deploying a template every time. So it's the same stuff that's going on here, and we only have a few parameters. This is our Windows server template. As you can see, variables. And we found out pretty quickly to keep those templates readable and understandable, we needed to limit the length of them. And we did that by creating a variable here called alert copy, and then each of our alerts are defined in here. That's just log alerts. Then we have one for metric alerts above this. So every event we want to monitor, we just need to copy this section and add a new one, and then modify the query that we're doing in that template. So that's the only thing we need to do, and then we'll have a new alert configured when we deploy this. So it's just running through everything here. If we go down here, this is the stuff that is going on. So this is looping through our variable and deploying each alert for as long as we have a new alert configured. And to show the deployment, I'm already logged in. Just need to make sure we gave it the right name. Yeah. there's some warnings just because Microsoft is changing things. And here you can see I'm logged in with my work account. That's my Solvo IT account. I'm deploying this stuff to my own environment, which is in a different tenant. But using this filter up here, this is the Lighthouse configuration I told you about, I can select which environment I want to use. And hopefully we have a deployment. Let's check. So there it is. And it's still deploying. So there's the automation account, and there will be a workspace and then a few other configurations, but not much yet. That's where we are deploying our solutions after that. This is just the basic part of it. So I talked a bit about it. We use some third-party tooling to get alerts because Azure Monitor can do this in different ways. We can get notifications by email or by using the Azure app on Android or iOS. It's not enough for us to use that part. There's not enough options in there to configure who's on duty, do we need some escalation and stuff like that. So we decided to use Signal 4, mostly because we've worked with Datadog for a long time now. We used it in our Scrum environment too. But now we wanted a cloud-based solution, so we didn't have any servers to maintain. And this is their product for that. A good benefit of this is that we're using Azure AD single sign-on, so we can sign in with our own work accounts. We have apps for Android and iOS, and we can configure all these teams we want in there, like who's on duty and defining calendars like that. And then we can do escalations. So one of our managers gets the notification if we don't react to it. So our initial approach with Signal 4 was to use webhooks. That's what we like to use because then we could decide exactly what information got forwarded. It turned out that this didn't close the alerts in Signal 4. So if we got an alert from a customer saying that this service is down, you need to go in and start it, it wouldn't close the alerting again in Signal 4 if the service started by itself or someone else did it. So we needed that part, and we talked to Datadog saying, what should we do? And they came up with a brand new Azure Monitor connector. Pretty quickly, actually. It was on their schedule, but they needed to speed it up for us to be happy. So they did that development, and we got a two-way integration. So now alerts are closing, and we actually don't need to configure any webhooks or stuff like that. It just looks at our environment and pulls all the alerts that are there, and we want to get them. So another requirement for us was that only critical alerts would trigger notification to Signal 4, because we don't want to wake up people for just small stuff. And that part is done now in the connector too. So to configure Signal 4 and set it up, we just need to create an app registration in the Azure AD tenant. We need to add a new Azure Monitor connector in Signal 4. And then we need to decide if we want suppressed alerts in Azure Monitor to be sent to whoever is on duty, or if we want all severities or just severities 0 and 1 or stuff like that. And that's all we need to do. Then they will have an app registration, so they can go and read all the alerts and change the state of them if we change it in the app. So whenever we acknowledge an alert in the app, it will get back to Azure Monitor. That's another cool function that we needed, because we also have our ticketing system, which needed that update. So The connector we have there is also pulling this data. So whenever we update the alert in either the app or in the portal or in our ticketing system, this will get synced between them. And here's just a view of it. It's not available there yet. They can help you set it up if you're a Signal 4 customer. But this is what it looks like. Just need to enter in your subscription ID, tenant ID, app registration information, and decide the severity and suppression. So our ticketing system, Topdesk, as I said, we didn't have anything half a year ago for our operations manager system. We just got it. And another requirement for getting that was that it was a cloud-based solution. We didn't want any servers running. And another requirement, again, Azure AD single sign-on, which they have. We could get that other places, but ServiceNow and stuff like that was too big for us to onboard. Topdesk was a better size for that. And this is also our new console. So whoever is on duty that day will look in that console to see if anything new happens. And there's a connector from a company called The Backbone. It runs in a server. Unfortunately, it's not a service we can use, but we'll get there at some point. There's an easy configuration through an XML file where you just define your environment. This is done through an app registration too. It just needs the permission to update the alerts, and it needs permissions in your Topdesk environment. That's all. It's also a two-way integration, as I said. All alerts that we have is triggering a ticket. So no matter what severity or anything, we'll get a ticket based on that alert. One thing we had in our operations manager environment that we don't fully have yet is targeting or scoping. So we can't scope a solution or management pack to just a few servers, at least not our own custom ones. This is only for Microsoft solutions so far. So change tracking and Azure Monitor for VMs, we can do scoping on those, but not for our custom things. And it's also only for agents that are connected directly to Azure Monitor, so not through Operations Manager. We're using it right now on the Microsoft solutions, but we need to get there where we can do that on our own solutions too. It's quite easy to use. You just create an Azure Monitor computer group, also called Log Analytics computer groups. It's based on either a Log Analytics query, where you distinct the computer, or you can sync them from Active Directory or Vsauce, if you have that running. And then you create a scope configuration in Log Analytics, and you do the targeting on the solution itself. So it's quite easy to configure, and in a scope configuration, you can have multiple computer groups. Alert groups and rules. Those are different parts of Azure Monitor where you can do alert notifications and other stuff with your alerts. So alert groups are based on just a collection of notifications and actions that you want to do on a single alert. It's configured per alert you have in your environment. So if you have 500 different alerts configured, you need to configure this for each of these alerts when you create them. This is very good at some point where you want to do something with just that alert. If you want to do something more flexible and more at scale, you can use alert rules. This is based on a filter you create. So maybe you want all severity 0 alerts to get forwarded to Signal 4 to handle those on your on-call duty. This is where you use alert rules. This will override everything else you have defined. So even though there's other things configured, you can use alert rules to override that. Yeah, can you use the mic?
Did you actually talk about action rules rather than?
Yeah, yes.
Because the correct terminology would be action rules.
Yes, action rules, exactly. Sorry about that. You can also do suppression here. So we needed this functionality too before we made this migration to Azure Monitor, because our customers work on their environments and they don't always tell us. But when they do, we want to suppress alerts so we don't get waking up in the middle of the night. The cool thing about suppression alerts is before that we had to disable the alerts and we didn't get any information about if something was wrong during that maintenance. With just the suppression of alerts, we still get the alerts, but we just don't get the notification. So that's what's happening there. And let me just show you that part. It's configured in Azure Monitor under Alerts. And here you have the action. So yeah, as you said, action rules, not alert rules. We have action groups here, which is quite simple to use. You just need to give it a name, select the subscription where you want to save it, and a resource group. Then you define whatever action you want to get here. So you can trigger an automation runbook in Azure Automation to run. This could be if a service stops, trigger this runbook to start it again. Some basic stuff. You can use Azure Functions. You can get emails to a specific role in Azure. You can get emails, SMS, voice calls. You can integrate this into ITSM systems like ServiceNow. Unfortunately, not Topdesk as we use, but other systems are there. We can use logic apps and secure webhooks. So it's quite easy to configure. You just need to apply that on your alert. Alert rules is also easy to configure. You just need to select a scope. That would be your application that you're doing maintenance on. So if you have all of the components of that application in a resource group, you can just select that resource group. Or if you have a single subscription just for that, you can do it on the full subscription. Let me just select something here. Then we have the filter here. So we can select on severity. We can even search for words and just in the text that the alert is sending. So that's free search. And you can monitor different services and stuff like that. You're going to even have conditions in here. So we just want to select all alerts with the severity 0 here. Then we need to select what we want to do. So an action rule uses action groups too. So it's not like you can have one without the other. You need to have action groups. But here you can suppress if you want to do that. So let's say we have a maintenance window. And you can do this based on a schedule, or you can do it as a single time or with recurrence. Just a single time for now. So we have Ignite maintenance. And we need to select where to save this. That's all you need to configure a maintenance window in here. We had the issue when we did this in Operations Manager that the guy doing it needed to know exactly what servers or services he needed to do this on. You need to do that here, but it's easier to just pick an application and saying this is where we are doing maintenance than having a full system of servers and defining that. So at least we think this is easier to use. Yeah.
Have you tried the AI solution for monitoring?
We did try it. We haven't used it in production yet because we're still learning. It's new for us, all of this too. I guess you mean AI, like looking at performance counters and finding, yeah. So that's one thing in Azure you can do. An alert based on a performance counter, a metric. And if it's not within the usual performance of that application, you will trigger an alert. So you don't have a static threshold, it's a dynamic threshold instead. We're not there yet where we're using this, but we want to use it, and we want to use it soon. So. Some of the learnings we had during the past 6 months during doing this, we needed to understand that we could not offer the same as we did before with Operations Manager. In the beginning, we would only be able to offer a lot less, actually. But as we got started, we got to the point where we can now add a lot more features to this, and we can actually do the stuff the customers are asking for. Dashboarding, we don't just have one product. Right now we are using Squared Up with Operations Manager. They just got their extension to Azure Monitoring, but they are not at the point where we want to be in that situation because they still require servers. We don't want to introduce any servers in our environments now. So until they have a cloud-based solution, we're looking at other stuff or integrating with the customers' dashboarding tools. I know they're working on it, Squared Up, so again, go and tell them you want it. The cost of all this, we can, of course, do a lot of calculations on this and try to predict what it's cost, but we don't know how much data a server is sending at a customer. We thought that the retention of the data would be the cost part, the most cost-heavy part of this, but it shows us that ingestion is actually the expensive part, at least up until a point where we are storing data for like 20 months. And we did some Excel to calculate this. I can show you that part. It's not totally perfect, but at least it gave us some insights into what we're selling the customers. So we just have a table with all the cost defined in there. And then we have some input from the customer. How many servers do you want to monitor? How much data do you expect to send? They can never answer that, so we just have a number here that is what we've seen so far. Then we enter in the number of alerts that we have configured. This depends on how many solutions they want. That's a different cost for metrics and different cost for alerts. And if they want change tracking, we can do that in there too. And then we just have a simple table over here showing each month how the cost is growing for the customer depending on the retention part. But as you can see, ingestion is the expensive part up until about month 20 to 22. So that was a surprise for us, at least. So where are we going now? We need to do more custom monitoring for customers. Now we have that option available just to use. We need to do more monitoring of Azure resources. Right now it's mostly based on servers, but we can quickly integrate with the customers if they have anything they want to do alerting on. We need more automation. I couldn't find a good picture of that other than robots in a factory, but I thought this one was better. And then we need to do DevOps. We need to get to the point where we can automate the deployment fully. Right now we still need to run the script for each customer when we deploy it. So that's all I had for you. I'll be at the Squared Up booth at 3:30 today. If you have any questions, I can also answer after this. And then I'll be at the theater tomorrow where we're all hungover. You can also reach me at Twitter or on my blog. So thank you for coming.